let's determine if an argument is valid using a truth table. Now, when I think about arguments, I'm certainly not going to sit down and create a truth table, but let's pretend that we are dealing with logical statements, and therefore this makes sense. So, what does it mean for an argument to be valid? Well, if we're talking about a truth table and we're looking inside a truth table, it means we have all true values. So as you're looking down the column, everything is true. If you have even one false statement, it is not a valid argument. So, okay, here we go. Given the premises, if an animal has 9 lives, then it is a cat. So that's the first. And we're given Stripes is a cat. So is it a valid argument to conclude that Stripes has 9 lives? Now, you can see below that we are breaking these two statements down and saying, okay, P. We are going to note P as something that has 9 lives. That's P. Q is a cat. So if we look at the first statement, if an animal has 9 lives, so if P, then it's a cat. So our first premise is if P, then Q. The second part is Stripes is a cat, which is just Q. We're trying to conclude, so that's premise 1, premise 2. Our conclusion is Stripes has 9 lives, which is simply P. So if we have if P, then Q, and Q, does that imply P? Whew. Let's look at this in symbols, okay? So we have P and Q, right? You'll notice the first thing that I said was if P, then Q, right? If an animal has 9 lives, then it is a cat. Then we go one step further and say, if an animal has 9 lives, it's a cat. That's this part. And Stripes is a cat. So and, there's our symbol for and, Q. So if P, then Q, and Q. And then our final statement says, if all of that is true, if P, then Q, and Q, does that then imply P? That is our final piece. So, because we're trying to figure out if this is a valid argument, we are trying to see if that final column has all true markers in it. If it's T's all the way down, we have a valid argument. Okay, so let's fill out our truth table. First things first, P, because it's we have 2 things, so 2 squared is 4, so we're gonna have 4 lines. True, true, false, false. Our Q value will be alternating true, false, true, false. And then we go to our first piece, which is a conditional if P, then Q. And remember, for a conditional to be true, to be false, it's the easy one. If we go false, or true, false, it leads to false. Everything else is true. So true, true leads us to true. The second line, true, false, that is the only time a conditional is false. False, true is true, and false, false is true. Okay, so that now leads us to the next one. So the next column is if P, then Q. That's this column, and Q. Now recall, if we have the and connector, that means for something to be true, both pieces have to be true. So as we're looking, true, true gives me a true. False, false is false. True, true is true. And true, false is false. Right, because I was looking here. True, true, false, false, true, 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 false. Okay, great. So now we're going one step further, and we're looking at this one, right? If P, then Q, and Q, then P. Okay, so our first step is here. So again, remember, the only time this will be false is if we have true, false. Okay, so first one, I have true and true. 2 trues is a true. Next one, I have false, true. Well, in a conditional, false, true is true. Then I have true, false. Wah, wah. True, false is false. The last one, false, false, is true. Therefore, because we're looking at this and we have a false indicator as part of our line, this is not true. This is not a valid argument using truth tables. All right, so that's the case. That's how we work it out and look at it with truth tables. But it comes down to we don't have all true, so this is not a valid argument. Thanks.